Animations can make or break user experience. When done right, they make websites feel smooth, intuitive, and visually appealing. In this video, we will use Anime.js to effortlessly add polished motion to your site with minimal setup. First, we will add animated text by creating a container and placing a text component with a class we can target. In this case, I will give it the class name text. Then we will use useEffect to ensure the animation runs after the component bounds. After that, we can use Anime.js text plugin to split the text into individual characters. This container uses overflow clip to clip anything outside its bounds and prevent unwanted scrollbars during the animation. Next, we animate the characters on the y-axis. Each letter slides up into place, pauses briefly, then continues up and out of frame. The motion uses easing a 15 millisecond stagger between characters and loops continuously. And here is the result. You can see each letter sliding up smoothly into place, pausing just for a moment and then moving out again. The stagger creates this flowing wave effect across the text, which loops continuously. Now you want to add an SVG animation below the text. We define an SVG, I got this one from Anime.js documentation, and add a class for targeting. I will use line. Then we convert it to a drawable, and animate a line drawing effect. It starts hidden, draws from left to right, then fully appears. The animation runs for 2 seconds with smooth in-out easing, staggers each line by 100 milliseconds and loops. And here you can see the SVG animation in action. Each line draws itself progressively from left to right, creating this satisfying reveal effect. The staggered timing means each path starts drawing just after the previous one, building up the complete illustration smoothly. Now let's add a timer. First, we create a reference for the timer element using useref so we can update its value later. Then we add a text component with an initial value of 0. We also add a reference to the element so we can update its value. Finally, we use createTimer function inside the useEffect to update the content on each frame with the current iteration time with a delay of 500 milliseconds. And here is the result. After a brief delay, a timer appears and starts counting up in real time. It updates smoothly, showing the elapsed time right on the screen. By default, animations start on page load, but we can trigger them only when they appear on screen. To do that, first we add a reference for scroll container and we pass it to the root div. Then we use the onScroll function, passing a container to monitor for scrolling and a target to watch for visibility. When the target shows up, the animation plays automatically. Also need to ensure that the container is scrollable, so we define a hide and set the overflow on y-axis to auto. And here is the effect in action. Instead of running as soon as the page loads, the animation waits until the target actually comes into view. As I scroll down, the element smoothly animates right when it appears on screen. Next, we will create 4 animation demos. Each one gets a class as an identifier, then we animate them. But before that, let's create a random function that we can later use to add organic variation to the motion of the components. For the first, we add a square component and give it a class name animation1. Then we use the animate function to animate this component with a 500 millisecond delay. Randomize x and y between defined pixel values, rotate and loop the animation. We add a random loop delay, refresh values on each loop, and start on scroll. For the second animation, we create a square component and give it a class name animation2. Then we keep the same settings as animation1 and add a random scale from 0.5 to 3. Then for the third, we create a square component with class name animation3 and we randomize its border radius between 0 and 100% for a morphing effect. And for the last animation demo, we create a square component with a class name animation4 and give it the same animation as the first 2 demos with the addition of random skew values. And here are the results. In the first demo, the squares drifts around randomly and rotating at different angles. The movement feels fluid because each loop generates new values. In the second demo, the square not only shifts and rotates but also scales up and down between very small and very large sizes, giving a zooming effect. In the third demo, the shape morphs constantly as the border radius changes, transforming smoothly between sharp squares and perfect circles. And in the last demo, the shape twists with random skew values, so every movement feels distorted in a different way, creating a dynamic, playful effect. We can also improve the design of the square components by giving each one a random color by using this function. And then we can go ahead and apply it to the component style. And here is the result. Each square now starts with its own unique color, some bright, some muted, creating a vibrant mix across all 4 demos. Next, we add a draggable element. To do that, we need to create a container for the draggable component and give it class name of drag container, and create the component itself and give it class name of drag. Next, inside the use effect, we use the create draggable function and set release stamping to control the speed, distance, and bounciness after release. By default, it can move anywhere in the window, but by passing the container, we limit its movement. And here is the result. You can now click and drag the element around within its container. When you release it, the element doesn't just stop, it continues moving with a smooth deceleration and slight bounce effect. The movement is restricted to stay within the container boundaries, so it can't be dragged outside that defined area. Lastly is the animatable object, and for this we have an object that follows the cursor when it enters a container. We start by adding a component and give it a class name for reference. I will call it circle. Then we use the create animatable function inside use effect, targeting our circle class. We set initial x and y positions to 500 pixels and add smooth easing for natural deceleration. For mouse interaction, we first create a reference and pass it to the component. Then we add an event listener to the reference which calls the onMouseMove handler that calculates the mouse position relative to the container center. We get the container's bounce, find its center point by dividing width and height by 2, then calculate the mouse offset from that center. We use utils.clamp from Anime.js to keep the circle within the container's boundaries, preventing it from moving outside the defined area. Then we add a mouse leave handler that returns the circle to the center position when the cursor exits the container. Next, we return a cleanup function from the use effect to remove the event listeners when the component unmounts. This prevents memory leaks and ensures the listeners don't persist after the component is destroyed. And here is the result. When the mouse enters the container, the circle follows the cursor around inside it. As soon as the mouse leaves, the circle smoothly returns to the center. Finally, we set up real-time updates for the coordinates. We first add HTML component to display the x and y values, and we create a reference for each. Then we attach an onRender callback to the x animation, which runs on every frame where the circle is moving. Inside that callback, we read the current x and y from the animatable and update the two readouts, reading to two decimal places with utils.roundPad. And here is the result. As the circle follows the cursor, the x and y values update in real time, showing the exact coordinates inside the container. And that is the final result, a site packed with interactivity. We've got animated text and SVGs, a live timer, random motion demos, and even draggable and cursor tracking objects, all working together in one place. It's a great showcase of how much personality you can add with just a few simple animations. Thanks for watching. If you found this helpful, don't forget to like, subscribe, and hit the bell icon for more tech tutorials.